All right, in this video we're going to take a look at a few even problems from the homework so you have an idea of what you're getting into before you start the homework. Before we get started here, I should point out that there is a lot of stuff in the reading for this section. And I think it says it in the homework assignments, but from here on out, there's going to be two different methods, and we're only going to use one of them. We're going to use something called the p-value method. There's also something called the critical value method, which we're not going to use. So from here on out, for the rest of the quarter, anytime the book says something about find a test statistic or a critical value, you can safely just ignore that. And in the reading, when they talk about using test statistics and critical values, you can ignore that part too. Okay, with that said, let's move forward and look at a few examples. So I want to start with looking at number 6. And this one just says, express the original claim in symbolic form and identify the null and alternative hypotheses. Okay, so looking at number 6, you've got a claim. It says when parents use X sort, proportion of baby girls is greater than 0.5. So there's where you should pick out that they're making a claim. I mean, they started it with the word claim, which helps too, but they won't always do that in the problem. So there's the claim. The latest actual results, that is talking about a sample, right? So that's not the actual claim. That's how a particular sample came out. So when they want us to express the original claim in symbolic form, it's about a proportion. So I will use the P symbol. And what are they saying about the proportion? They're saying the P is greater than 0.5. That's done for part A. Part B says identify the null and alternative hypotheses. So for part B, you have to say, well, one of the hypotheses is the original claim that P is greater than 0.5. The other hypothesis is going to have to be the opposite of that. It's less than or equal to. So either greater than or less than or equal to. One of these is the null, and one of them is the alternative. And keep in mind, the null is always the one that has the equal sign. So when you read this bottom statement here, it says P is less than or equal to. And there's the key, right? There's the equal sign. So the bottom statement is the one that becomes the null hypothesis. And the top statement, which happens to be the original, becomes the alternative hypothesis. Okay, that's it for number 6. We've expressed the original claim and we've identified the null and the alternative hypotheses. So I'm going to skip ahead a little bit to 10. So 10 says, go back to exercise 6. But they say, make a subjective estimate to determine whether the results are likely and state a conclusion about the original claim. Okay. So let's see. Let's get back to what am I doing here? Okay. There we are. Let's get back to that because we never used these latest actual results. So the latest actual results showed that out of 945 babies, 879 of them were girls. So the sample came out that 879 out of the 945. I don't know what that percentage is, but it's pretty high. Let's see. Let's get 879 divided by 945. Yeah, it's like 93%. It certainly seems like that supports the alternative hypothesis. The null said that it was less than or equal to 50%. The alternative hypothesis said it's greater than 50%. This came out way greater than 50%. Again, we're not actually going to draw curves to compute these, but if we did, we would base our curve on the null on 50%. And say the null says it's either going to look like this or even lower than that, right? If it's less than 50%, but this is the highest that we can get. And 93% is probably over here, probably underneath my head, actually, right about there, I'm guessing. But yeah, 93% is way off the edge of this curve. So if the rate's really 50%, or maybe even lower, our sample seems practically impossible. So in this case, I am going to say, seems like we're probably going to reject the null. In the next section, what we'll do is compute the probability of getting 879 out of 945 if the null is true. And we'll find out the probability of this happening is like really tiny, way less than 5%, right? It's unusual. So we'll reject the null. Okay, so that was 6 and 10. Let's see if we can move. Oops, that's 10 again. Let's see if we can move on. I'm going to look at 26 and 28. Those are assigned homework problems for you, so spoilers. If you want to try them on your own, and I kind of encourage you to try them on your own, hit pause right now. Try 26 and 28 yourself, and then come back and watch the rest of this video. So I'll do 26 and 28 since you can't check your answers in the back of the book for those two. Okay, so let's take a look at 26. So we're supposed to do two things here. We're supposed to state a conclusion about the null hypothesis. In other words, that we reject it, or maybe that we don't reject it, fail to reject it. And then without using technical terms, say what it means. And that's really going to be the key for us. If we can't explain what this all means, it's just a bunch of fancy number crunching that doesn't help anybody. So let's look at 26. If we need to state a conclusion about the null hypothesis, first of all, we need to know what the null hypothesis even is. So let's start there. The original claim, fewer than 20% of M&Ms are green. So that's a claim about a percentage, proportion. Fewer than, less than, 20. The opposite claim would be greater than or equal to 20. The one that has the or equal to in it is going to be the null hypothesis. That will tell us where to draw the curve. The other one's going to be the alternative hypothesis. So what they're saying now is the hypothesis test results in a p-value of about 7%. So let's talk about what that would mean. So giving the null the benefit of the doubt, it means you draw a normal curve centered at 20%. And the null says it's either 20% or it might even be greater than 20%. So the only way we'll reject the null is if we see something way down here in the bottom, on the left. I should pause and take a little side note here. So if you look in the back of the book for the null hypothesis, they'll actually rewrite the null hypothesis. This is the null hypothesis, what I'm boxing right here. And it is totally fine with me if you just write your null hypotheses like this. The book, though, says, hey, when you draw your curve, and you can't center a curve on a range of values. You have to pick one place to center your curve, and we do center it on the equal part of the null. Right? That's why. That's why it's the null. It's because it has that equals. So if you look in the back of the book, they will write the null hypothesis like this. That's based entirely on the fact that we need to draw the curve somewhere. And that's where the null says. So this is sort of the other form of the null. That's okay. I actually prefer the original form of the null over here and just recognize that we are going to center the curve at 20%. But either one's fine. If you want to match the back of the book, they will turn all of their nulls into equal signs and draw the curve at that spot. Okay, all that to say that the hypothesis test came out with a p-value of about 7%. They're not even telling us how the sample came out, but apparently it came out lower than 20%. It came out about right here. And the p-value says the probability... Yeah, I don't even know what the sample was, like if it was 3 out of 100 or whatever, but the probability of the sample was 0.0721, which granted is kind of in the bottom end of the curve, but not far enough, right? It's not unusual. It's not less than 5%. So our sample was not unusual. It's close, but not unusual. Because of that, I don't quite have enough evidence here to reject the null. Don't reject the null. And don't reject the null is still a very technical statement. We need to write without using technical terms, state a final conclusion. So we could not reject the null. We could not go with the alternative. I can say it either of those ways. Since the original claim was essentially the alternative, I'm going to talk about the original claim and just say there was not enough evidence here. So there's not enough evidence to prove the claim, to prove that fewer than 20% of M&Ms are green. And again, keep in mind here, apparently our sample did come out less than 20%, but not convincingly less. They're saying it's possible the rate really is 20%, and this was just normal fluctuation around the 20% rate. It's not so far off the curve that I feel like I have to reject the 20% idea. All right, let's look at one more example. This is 28, similar idea and same instructions as 26. But we'll try to run through this one a little bit faster. So 28, women have heights with a standard deviation equal to 5. So let's get the symbol for population standard deviation is this. It's sigma. It's Greek S. So women have heights with a standard deviation equal to 5. The opposite of that claim would be the standard deviation is not equal to 5. The null is going to be the one with equal sign. The alternative is going to be the one without the equals in it. The p-value this time is pretty tiny, 0.0055, less than 1%. Let's draw a curve just to talk about what's going on here. As usual, it's a terrible normal curve, but as usual, the null is our benefit of the doubt. We'll start by saying, suppose standard deviation is 5, then samples should come out like this. Our particular sample, I don't know if it was too high or too low, but it was way away from 5, right? So maybe it was way up here. and its probability, the tiny little bit of area here that it chops off. So that's where the sample came out. The tiny little bit of area that it chops off is 0.0055, which means our sample is unusual if the null is true. Which means I am going to reject the null. And my sentence that makes sense of this in terms of ordinary English language would say something like, there is evidence that the standard deviation of women's heights is not 5 centimeters. I don't know what it is, but my sample was so far off the curve that I'm going to say I don't buy this curve. It's not 5. It's something else. So I know this section is designed to just be essentials of hypothesis testing to give you the idea. And starting with 8-3, we'll start actually computing p-values ourselves, and I think that'll help make the process more comfortable. Here we're trying to use all the language without actually being able to crunch the numbers, which is a little bit weird, like we're not doing the whole process. But do what you can with getting yourself comfortable with the language and ideas here in 8-2. And starting in the next section, 8-3, we'll get the full process, and I think you'll get a little more comfortable with it.